VR is based on technique developed in VR and interact not only with a virtual world but has a degree of interdependence with the real world. VR and AR are breakthrough technologies that start to revolutionize the pattern of pupils' interaction with virtual environments. The paper tries to explore the current use of VR and AR, identifies key issues related to their implementation, and considers future direction that may shape their role in a modern society. Next, literature review pages. For the first one, my dependent variable is impact on modern society. Virtual reality and augmented reality have emerged as transformative technologies that have reshaped the way individuals interact with digital and physical environments. The impact of VR in AR modern society, including all aspects like social, economic, education, and cultural, is the dependent variable of the research study. The next one is usage, trend, and adoption. AR offers enhanced experiential learning through better visualization of abstract concepts in education, while surgeons use VR for pre-surgical rehearsal and trainees in medical and engineering streams. Next is social and physiological impacts. VR can result in sensory disorientation, reduce empathy, and escapism if applied for extended periods, whereas AR will blur boundaries between reality and digital augmentation, which might have implications for attention span, social interaction, and privacy. The next one is technological limitation and accessibility. The high-end VR system demand high computing power and needs special equipment with stable connectivity. Therefore, access is limited in low-resource settings. Lastly, future development and research direction. Convergence with wearable technologies, 5G network, and edge computing promises seamless real-time experience. Next one is technical description of how the technology operates, including basic function. For the first one is virtual reality. The backbone of VR technology is a hardware and software integration. Hardware such as head-mounted display, HMDs, motion controller, sensor, and spatial audio system are integrated to provide feeling of presence and immersion. On the software side, rendering engines create three-dimensional environment in real time while tracking algorithm, visual, and audio feedback to user action. Next one is augmented reality. AR works through devices such as smartphone, tablet, and glasses that are equipped with cameras and sensors to capture and interpret the space around them. The basic function of AR is to provide real-time augmentation that improves decision-making, engagement, and interaction. Lastly, comparative functionality. For first-man environment, AR combines both real and virtual objects coexist in the same space and in real time in real environment, while VR requires totally immersive in the virtual world environment. Next, user view. AR allows the user to see the real world around him and the virtual object, while VR users see the virtual environment only. Next, 4.0, that's where technology is being used. First one is on education. These technologies will give students an opportunity to learn in an interactive way by creating an immersive experience which will result in better retention than just by learning using textbook. This next one is a healthcare. VR is already used in surgery training, rehabilitation, and therapy for providing immersive simulations where a practitioner can hone their skill without posing any risk to patient, while AR aids doctor during live procedures or relaying patient data, anatomical guides, or diagnosis image directly into the surgical field. Next, retail and e-commerce allow customers to virtually try on clothes, accessories, or cosmetics to reduce uncertainty and enhance purchase confidence. Next one, entertainment and media. VR provide ultimate gaming experience, while AR enhance sporting events, concert, and sport performance with static visual effect or even interactive elements superposed on the actual performance. Next, we continue with current research direction or anticipate future developments and their significance, increasing the realism and immersion aspect through improvement in haptic feedback, eye tracking, and full body motion capture, the integration of AI-driven personalization into VR and AR systems, the advent of 5G and edge computing is expected to revolutionize VR and AR application in terms of scalability and responsiveness. Investigating cross-platform interoperability where VR and AR system can operate across multiple devices and operating system types, and also ethics and societal considerations. So we move to the impact and issues of the technology for social, economy, and education. For the social, VR can enable people to connect in shared virtual space, allowing them to collaborate and interact globally without geographical limitation, while AR enhances daily experience by embedding contextual information into physical setting, supporting navigation, tourism, and real-time communication. For the economic, firms utilize AR in making consumer experience better. For instance, virtual product trials in retail, while VR enable immersive marketing campaign and interactive brand storytelling. For the education, virtual reality is well known for its capacity to attract the attention of students and maintain their engagement through the learning process, making it useful tool for both traditional and online education settings, while AR in education interactive components such as 3D models, movies, and other materials that can be accessed through a smartphone or tablet can be added to standard textbook with the use of augmented reality, which can be significant improvement over the status quo. Next, we move to analyze the usage of the technology in society. In the 1990s, AR research shifted toward wearable device and marker-based tracking system, but today AR is widely used in mobile applications, games, advertising, retail, and industrial training. Yearly, VR systems were bulky and expensive, limited their adoption to specialist industry, and it was not until the 1990s that consumer-grade VR systems started to become more accessible with introduction of affordable headset and graphic processing units (GPUs). VR use a headset that covers the user's entire field of view and provide a 360-degree view of a virtual environment, while AR overlays virtual objects onto the real world using a camera on a screen. In conclusion, virtual reality and augmented reality have emerged as transformative technologies that reshape modern society fabric in social, economic, and educational domains. Their development from experimental prototypes in the 1990s to mainstream application in the 2010s and widespread integration in the 2020 reflects both technological innovation and increasing recognition of immersive technology role as essential tools for human development.